Hello everyone, my name is Mary Kate Shaughnessy and I'm presenting my thesis to you all today. Thank you for listening and I really hope that you enjoy it. As you can see on this slide, there are three main topics discussed within the introduction of my thesis that contribute toward the purpose of this research. The three topics that will be discussed are errorless learning, video modeling, and paraprofessional training. The first topic I'm going to review is errorless learning. According to Wiemeyer and Palmer in 2003, students with intellectual disabilities continue to require a significant amount of support in order to learn as independently as possible. Due to an increase in students with intellectual disabilities, there has also been a large staff increase as well. Many of the staff that are hired to help with the students with intellectual disabilities are known as paraprofessionals. Paraprofessionals are individuals who assist the classroom teacher in the classroom and work with the students. One effective way that students with intellectual disabilities learn material is through an instructional strategy called errorless learning. As described in Kern et al. In 2008, errorless learning is a compensatory instructional intervention based on the idea that learning is stronger when it occurs in the absence of errors, with the main objective being restricting an occurrence of an incorrect response by using behavioral procedures such as stimulus modification, response prompting, or self-instruction. Other studies have demonstrated the effectiveness of errorless learning as well. In studies conducted by Fillingham, Sage, and Lambson in 2006, and in another study by Ducharme, Lucas, and Ponce in 1994, errorless learning was found to be effective at increasing paraprofessional performance, and in most cases resulted in increased student outcomes as well. Sulzer, Ozroff, and Mayer in 1991 published a book entitled Behavior Analysis for Lasting Change. They stated on page 315 that the primary problem with errors is that once they have occurred, they are much more likely to recur. Errorless learning helps in reducing this problem by eliminating the opportunity to respond incorrectly. The next topic that we're going to discuss is video modeling. One way to instruct paraprofessionals on how to implement procedures is through video modeling trainings. Past research has demonstrated that video modeling increases paraprofessional performance. In studies by Singer, Sowers, and Irvin, and in another study by McCulloch and Noonan in 2013, video modeling proved to be the superior strategy in instructing paraprofessionals in various skill areas. The last topic that we're going to be discussing is paraprofessional training. Errorless learning, when implemented correctly, can produce positive outcomes for students. When paraprofessionals are not trained in how to implement the procedure, however, it will not benefit the students with whom they are working with. Previous studies have researched paraprofessional trainings. Rispoli in 2011 discussed how alarming the increasing use of paraprofessionals was because typically they have inadequate specialized training and experience. Within this study, researchers reviewed 12 current studies that focus on paraprofessionals that were taught to implement interventions with students. The procedures that they focused on within these studies were written and verbal explanations, modeling, video demonstrations, role-playing, and feedback. Positive outcomes for the paraprofessionals were reported in 92% of the included studies. Another study by Brock and Carter in 2013 indicated that when paraprofessionals are trained adequately, they are able to implement educational practices that greatly benefit student outcomes. The purpose of this current study was to expand upon previous research in order to demonstrate that instructional aid performance can increase as a result of a video modeling intervention to teach errorless learning procedures. We are now going to review the methods section of this study. We will review the participants, settings, materials, experimental design, inter-observer agreement, independent and dependent variables, and the procedure. This study had a total of 3 participants. All were female. They were chosen for the study based upon each participant exhibiting a skill deficit in implementing errorless learning with their students. The study took place within a self-contained special education high school classroom. All staff observations took place in this classroom, and the intervention took place in the back of this classroom. The materials used within this study were a pen and paper to track the correct implementation of the participants. All of the trainings were conducted at the desktop computers in the back of the classroom, which included a computer on a table with a chair in front of it. The video was played using QuickTime Player on the computer. The participants used a mouse on the computer to play, pause, or end the video that was presented to them. During all video training sessions, a pen and paper was also utilized by the procedural reliability observer in order to take data during each intervention session. The research design used within this study was a single subject, multiple baseline across participants. This design was used to evaluate the impact of video modeling on staff behavior. As stated in CASD in 2011, the multiple baseline design demonstrates the effect of an intervention by showing that behavior changes when and only when the intervention is applied. Momentary time sampling was the observation measure used within the study. There were 20 intervals within each session, and each interval lasted 1 minute long. At the end of each interval, when the researcher looked up, if the paraprofessional was implementing errorless learning procedures with the student at that exact moment, then they received credit for that interval. If they were not implementing the procedure, when the paraprofessional looked up at the end of that minute, they did not receive credit for that interval. In this research design, all 3 participants started in baseline. When stable performance was established for all 3 participants, the intervention was implemented to Dana. The other 2 participants remained in baseline. Once Dana exhibited stable performance, the intervention was then implemented to Emily. Dawn remained in baseline. Once Emily exhibited stable performance after being given the intervention, Dawn was provided the video training. The intervention phase for all 3 participants ended when stable performance was established. In order to ensure reliability within the study, inter-observer agreement sessions were conducted every 3 observation sessions. 2 independent observers recorded data on the percent correct implementation of errorless learning throughout baseline and intervention sessions. Trial by trial inter-observer agreement was used within this study. As discussed in Mayer, 1991, trial by trial IOA is calculated by the total number of intervals agreed by both observers divided by the total number of intervals and multiplying this by 100. The independent variable in this study was video modeling training. The video modeling training was defined as the 10 minutes in which the participant watched a video that instructed them on how to correctly implement errorless learning with the students. There were 3 dependent variables within this study. The first dependent variable was the percent correct implementation of errorless learning during instructional time. The percent correct implementation of errorless learning was defined as the total frequency of intervals per session in which the participant correctly implemented errorless learning procedures. The second dependent variable was the social validity questionnaire, which was a document completed by the participants following the study that prompted them to answer 5 questions in regard to their preference for in-person training or video training. The questionnaire allowed the researcher to gain self-report measures as to whether or not the video training was accessible, preferred, and easy to understand for the participants. The third dependent variable within the study was the generalization probe. The generalization probe was an observation session in which the participants worked with a different student than they worked with during other observation sessions. The generalization sessions took place 2 days after formal data collection sessions. Errorless learning was to be implemented with that student as well, and data was collected on their performance level. Procedural reliability was collected for 100% of the intervention sessions and was calculated at 100% across all training sessions for all 3 participants. During baseline, the observation sessions were conducted during period 2 of the school day, which began at 8:45 a.m. and ended at 9:40 a.m. The observation sessions were broken down into one 20-minute period using 1-minute intervals for 20 consecutive minutes. An iPhone timer was used to track the intervals. Once the timer went off, the researcher looked up to see if the participant was correctly implementing errorless learning with the student. If they were implementing it correctly, a plus sign was documented on the datasheet. If they were not, a minus sign was written on the datasheet. This occurred throughout each session until a stable amount of occurrences was observed for each participant, which ended up being 3 consecutive sessions for each participant. The video modeling, or in other words, intervention, began with an in-depth overview of what errorless learning was and for what populations of students it was beneficial for. It was explained to the participants that the students they are assigned to work with one-to-one would greatly benefit from implementation of errorless learning procedures, specifically during daily living class, in which they work on functional academic skills. The video continued on to explain how errorless learning works and how to use it with their students. It was explained that errorless learning was a technique used in which the students are asked a question and are not given the opportunity to respond incorrectly. Examples were given on how to use errorless learning, and then a role-play situation was demonstrated with the classroom teacher and a paraprofessional acting as the student. The classroom teacher stood next to the student and asked the student questions about the weather, date, and their personal information. The correct answer was gestured to or verbalized, so the student automatically responded correctly. After this, the paraprofessionals were thanked for their time, and the video then ended. If no questions were expressed, the instructional aide was then asked to implement the errorless learning strategy during daily living class that day. Once the instructional aide began daily living class with their student, data collection began. Generalization sessions began once stable performance was observed for each participant. During generalization sessions, each participant was assigned to a different student than they originally worked with during baseline and intervention sessions. They were told to use the strategy that they learned during training with a different student during the same time of day. They were given that student during this time as well. They were to also work with the student during daily living class. Data was collected on the total number of intervals per session the participant correctly implemented errorless learning with the student. Let's review the study so far. The flowchart on this slide provides a visual representation of the baseline, intervention, and generalization sessions. As you can see from this flowchart, we began observations and data collection during baseline sessions. After baseline was stable for each participant and data was collected, the intervention was implemented, which was video modeling training. After the video modeling training, we continued to take data on the correct implementation of errorless learning with the students, and then followed up with a generalization probe when stable performance was exhibited by each participant. We then provided a social validity questionnaire to the participants following the intervention in order to obtain information on the preference for in vivo training or video training by the participants. The graph on this page demonstrates the results from this study. The results indicate that the intervention was effective in increasing paraprofessional implementation of errorless learning procedures. The x-axis represents the session number for each participant. The y-axis represents the percentage of correct implementation of the errorless learning procedures by the paraprofessionals across baseline, intervention, and generalization phases. If you look closely at the graph, you'll notice that there are different types of data points. The data points that are filled in with black indicate data from baseline and intervention sessions. The data points that are not filled in indicate a generalization session. Let's look at the first participant's results. Dana, the first participant in the graph, began baseline sessions by demonstrating 0% correct implementation of errorless learning across all 3 sessions, with a mean of 0% accuracy. Following the intervention, she increased in level and trend as demonstrated by 80% accuracy during the first intervention observation session. She then increased in trend again by demonstrating 85% accuracy during her second observation session, a 5% increase from her first observation session in the intervention phase. In her third observation session in the intervention phase, Dana remained stable at 85% accuracy in implementation of the errorless learning procedures. There were no overlapping data points between baseline and intervention. Her percentage correct implementation across all 3 intervention sessions remained stable, so a generalization session was conducted 2 days later. The generalization session indicated that Dana's performance again increased by her demonstrating 90% accuracy during that session. Now let's look at participant 2's results. Elizabeth, the second participant in the graph, demonstrated 0% accuracy across all 5 baseline sessions with a mean of 0% accuracy. Following the intervention, she increased in level and trend as demonstrated by 80% accuracy during the first observation session. She then increased in trend again by demonstrating 100% accuracy during her second observation session. She slightly decreased in trend during her third observation session, demonstrated by 85% accuracy. She remained stable at this level during her fourth session, again demonstrating 85% accuracy. There were no overlapping data points between baseline and intervention. Her percentage correct implementation across all 4 intervention sessions remained stable, so a generalization session was conducted 2 days later. She remained stable in her correct implementation and accuracy during the generalization session, demonstrated by exhibiting 85% accuracy once again. Now, let's look at the third participant's results. Dawn, the third participant on the graph, began baseline sessions by displaying 15% accuracy. She then demonstrated 10% accuracy, a decrease in trend, followed by displaying 0% accuracy during sessions 3 and 4, which is another slight decrease in trend. During session 5, she slightly increased in trend by displaying 15% accuracy, but again decreased in trend during session 6 and 7, in which she displayed 0% accuracy in implementing the errorless learning procedure with her student. In session 8, she again slightly increased in trend by displaying 10% accuracy in implementing the procedure with her student. She was then given the intervention and immediately increased in accuracy of implementation of the errorless learning procedures, as demonstrated by a significant increase in trend and level, with 80% accuracy during the first intervention observation session. She slightly increased in trend during the second intervention session, as indicated by exhibiting 85% accuracy, and remained stable at this performance level yet again by demonstrating 85% accuracy during her third observation session. There were no overlapping data points between baseline and intervention. Her percentage correct implementation across all 3 intervention sessions remained stable, so a generalization session was conducted 2 days later. During her generalization session, she slightly increased in trend, as demonstrated by 90% accuracy in implementing the errorless learning procedures. The procedural reliability checklist that was used during all video training sessions by a second observer is shown on this slide. As you can see on this slide, the procedural reliability checklist consisted of 5 questions provided to the second observer during the procedural reliability data collection, which took place during each video training session for each participant. It was comprised of 5 questions that the second observer was to circle yes or no to when observing the participants taking part in the intervention. The statements ensured that 1. The staff member was only provided the video for instruction. 2. No questions were answered for the staff member during the video. 3. Feedback was provided at the end of the session. 4. The staff member listened to the video the entire time. And 5. The staff member watched the entire video. Procedural reliability results demonstrated 100% accuracy across all 3 participants during the intervention sessions. In other words, 5 out of the 5 questions were answered yes by the second observer across all intervention sessions. The social validity questionnaire that was provided to the participants at the end of the training is shown on this slide. The social validity questionnaire consisted of 5 questions. They were provided a ranking scale that included numbers 1 through 5. If they answered 1, it indicated that they strongly disagreed with the statement. By circling 2, it indicated that they somewhat agreed with the statement. 3 indicated that they were neutral about the statement. 4 indicated that they somewhat agreed with the statement. And 5 indicated that they strongly agreed with the statement. The first question asked the participants if the information provided in the video training was easy to learn and remember. All 3 participants stated that they strongly agreed with the statement. The second question asked if they preferred the video training more than an in-person training. All 3 participants circled 5 on this answer as well, indicating that all 3 participants strongly agreed that video training was more preferred than the in-person training. One participant wrote in a comment underneath that stated, "It was much easier to access than an in-person training." The next question asked participants if the video training was easy to access. All 3 participants circled 5, which indicated that they strongly agreed it was accessible. The fourth question asked participants if the video training was easier to understand for them than an in-person training. All participants answered with somewhat agree and did not leave any follow-up comments underneath. The fifth question asked the participants if the video training allowed them to easily access it in case they had any questions on the strategy. All 3 participants circled 5, which indicated that they strongly agreed with the statement. The results from the social validity questionnaire indicated that the participants preferred the video training over the in-person training. The current study demonstrated that video modeling was effective in increasing paraprofessional implementation of errorless learning procedures. The results support previous research. Severson in 2011 demonstrated that instructing staff how to correctly implement errorless learning procedures using video modeling, among other strategies, was successful in increasing their on-task performance. In a similar study, Robinson in 2011 demonstrated the effectiveness of video feedback on staff performance. The findings suggest that the training package was effective and efficient in increasing paraprofessional on-task performance. In addition, McCulloch and Noonan in 2013 study indicated that video modeling training was an effective alternative to in-person training within schools. Although this previous research provided a baseline for our study, we expanded upon these findings by using only errorless learning within the video training in order to prove the effectiveness of video modeling in regard to this procedure to be used with the students. We found that video modeling was effective in increasing paraprofessional implementation of errorless learning procedures. Although our study was effective in increasing paraprofessional implementation of errorless learning procedures, there were a few limitations that should be noted within our study. First, our study did not have any feedback sessions. It would possibly increase their performance if they were given feedback regarding whether or not they implemented the procedure correctly. Our study also used momentary time sampling. Although this is an incredibly efficient and research-proven observation measure, it does have a tendency to underestimate the total frequency of behavior. Our participants could have been implementing the procedure within any part of the 1-minute interval, but it was not counted because it was not being exhibited at the exact minute mark. In addition to these limitations, there were also no fading procedures taught for errorless learning. Our hopeful goal for the students is to increase their independence in skill areas, but this cannot happen if they are always being prompted towards the correct answer and never being given the opportunity to respond independently. Another limitation within this study is the number of participants. There were only 3 participants within our study, so we cannot say with certainty that this intervention could be an effective way for a wide range of participants. Future research in this area should focus on a different observation measure. It would be interesting to see the similarities and differences in data results using another observation measure, such as partial interval recording. It would be interesting and beneficial to see if the accuracy of implementation increases, decreases, or stays the same. In addition, future research should also contain a maintenance session. Although generalization sessions demonstrated continued effectiveness of the intervention, we want to make sure that the intervention was successful over time as well. Lastly, future research should also include more participants and a few feedback sessions. More participants would allow for the research to have more social validity, and feedback sessions would allow the participants to have more information on their ability to implement the skill instructed to them during the intervention. The results indicated that errorless learning procedures instructed through implementation of a video modeling training produced increased performance by staff that could be generalized across settings and students. All 3 participants within the study demonstrated increased skill acquisition after being shown the video modeling training following the training. By increasing the amount of paraprofessionals who are trained properly, we are increasing the amount of students who are instructed properly, which is a platform for student success and independence in the future.